What's up, APES team? In this screencast, we're going to start Chapter 7 and cover Section 7.1. The world can be divided into three climate zones. Around the equator, you have the tropical zone, or the tropics. Around the North Pole and the South Pole, you have the polar zones. And in between the polar zones and the tropical zone, you have the temperate zones, which are found in the mid-latitudes. The case study that this chapter starts off with is that of the temperate deciduous forest of the world. These forests are located in the mid-latitudes, hence temperate, and have trees that lose their leaves in the winter, hence deciduous. Temperate deciduous forests around the world are some of the most disturbed ecosystems that we have because they're located where people tend to want to live. This diagram shows where the polar, temperate, and tropical zones are located. The tropical zone is found in between 23 degrees north and 23 degrees south. The polar zones are found above 67 degrees north and below 67 degrees south. And the temperate zones are found in between those polar and tropical zones. This diagram shows the extent of temperate deciduous forest deforestation in Europe between 1000 BC and 1850. You can see how deforestation progressed and the extent to which Europe has been deforested over that time. In section 7.1, we're going to talk about all the different factors that influence climate. The first thing we should understand is the difference between weather and climate. Weather is the day-to-day conditions that we experience and include things like temperature, precipitation, wind speed, cloud cover, and air pressure. Climate are the averaged weather conditions. Meteorologists, or people who study weather, will use 30 years worth of data to determine an area's climate. For example, the weather in San Francisco might be hot on one day, but San Francisco's climate is generally cool. The Earth's main source of energy is the sun, and as a result, sunlight is the main driver of climate on Earth. Incoming solar radiation, or sunlight, is called insolation, and it's the angle at which the sun's rays hit the Earth that determine the intensity of the sunlight. For example, if you take a look at the diagram on the left, sunlight is hitting the equator more directly and more intensely than it is at the North Pole. The seasons on Earth are caused by the tilt of the Earth's axis. For example, when the Earth is pointed towards the sun, we experience summer. When the Earth is pointed away from the sun, we experience winter. During the summer and winter months, the number of daylight hours change. During the summer, we have more hours of daylight. During the winter, we have fewer hours of daylight. The Earth's climate is also influenced by ocean currents, which is the movement of water in our oceans. Ocean currents can be caused by two different things. Surface currents are caused by prevailing winds and the rotation of the Earth. Deep currents are caused by the redistribution of warm and cold water around the Earth, with warm water rising and moving towards the poles, and cold water sinking and moving back towards the equator. This diagram shows surface currents around the world. We have warm water currents and cold water currents depending on where these currents are moving water from. This diagram shows deep currents, with warm water rising and moving towards the poles, and cold water sinking and moving back towards the equator. Another type of current is called upwelling or an upwelling current. These currents occur when wind blows surface water away from a shore and deeper, colder water rises up to take its place. This water tends to be rich in nutrients and supports a lot of phytoplankton and algae growth. A good example of that are the kelp forests of California that benefit from these upwelling currents. The Earth's climate is also influenced by air currents, and air currents are caused by the uneven heating of the Earth's surface by the sun. Warm air at the Earth's surface will rise, and as it rises, it cools back down and then sinks. These air currents are also influenced by the rotation of the Earth on its axis. This diagram shows the different air currents that exist north and south of the equator and their effect on the ecosystems on the surface of the Earth. As mentioned before, the rotation of the Earth has an effect on both water currents and air currents. This is called the Coriolis effect, and it causes currents to curve right in the northern hemisphere and left in the southern hemisphere. Something else that affects climate is El Nino, which is short for the El Nino Southern Oscillation. This phenomenon occurs every few years and is caused by the shifting of winds that cause warmer, wetter water to be pushed towards the eastern Pacific Ocean. Water has a significant impact on climate because it has a high heat capacity. What that means is that water can absorb a lot of heat without changing much in temperature. In coastal areas, that means having a cooler climate because warm air over the land will rise and cool air over the water will move in to replace it, creating an ocean breeze. At night, the ocean breeze reverses and continues to keep things cool. This screenshot shows how temperatures along the coast are much cooler than temperatures inland. Again, this is caused by the high heat capacity of water and the breezes that this creates. Greenhouse gases create the greenhouse effect, which warms the lower atmosphere or troposphere and keeps the Earth warm and habitable for us. Greenhouse gases include water vapor, carbon dioxide, methane, and nitrous oxide. Human activity is increasing concentrations of greenhouse gases in the atmosphere, and as a result, we are enhancing or increasing the greenhouse effect and global warming. Mountains can also have an effect on climate by interrupting the flow of wind and causing something called the rain shadow effect. The rain shadow effect occurs when air moves up a mountain slope, cools down, and releases all its moisture. On the other side of the mountain, which we call the rain shadow, the dry air warms up and pulls moisture from the land, creating arid, desert-like conditions. This diagram shows the rain shadow effect. It shows how the rain comes down on the windward side of the mountain, or the side where the wind is coming from, and how there are arid, desert-like conditions on the leeward side of the mountain. This satellite image from Hawaii shows the rain shadow effect, where the windward side of the mountain gets all the precipitation, allowing vegetation to grow, and the leeward side of the mountain doesn't get any precipitation and is very dry. Cities can also affect climate by changing the topography or lay of the land, or by creating microclimates. One example is the urban heat island effect. Cities tend to use a lot of dark materials like asphalt that absorb heat. They also tend to use a lot of energy and create a lot of waste heat. So cities tend to be a lot warmer than these areas immediately surrounding them. This temperature map of San Francisco shows how San Francisco has different microclimates, with different areas being much warmer or colder than other ones.